Thank you for joining this lesson. We're going to discuss differentiation and its applications. In number 19, we are told that the displacement s of a particle t seconds is given by s equals to 4t power 3 minus 5 out of 2t squared minus 3t plus 3. Determine the part 1 or part A, the velocity of the particle when t equals to 3. So what we are having here is displacement against time function. This is to mean that for us to get velocity function, then we need the gradient function of the displacement function. In simpler terms, because when you differentiate a term, you usually get its gradient function, then we should understand that right from linear motion, if you have a graph of displacement against time, which is a smooth line, the gradient for such a graph will give us velocity. Therefore, because differentiating a function gives velocity, gives the gradient function, then differentiating a displacement time function will give us a velocity function, which is the gradient function. So we're going to get gradient function, which is the differential of s with respect to time. Therefore, for us to differentiate the first part in this polynomial, we need to drop the power, which is 3 times 4 to give us 12. Then t now becomes power 2. The power reduces by 1. Again, we have to drop 2 here so that we have 5 over 2 times 2, giving us -5. Then t now becomes power 1. Then we will have negative. Because t is to power 1, we drop 1 here and it remains -3. And the t which was to power 1 now is to power 0. It becomes 1. Then the last part, which is a constant, there is an existing t here, power 0. That is why its value is 1 and it's not indicated. Therefore, t which was to power 0, when the 0 is dropped here now, during differentiation, the constant here disappears. Therefore, we will end the differentiation at that point. Now, this is the velocity function. We are told to find velocity of the particle when t equals to 0. Therefore, the value of velocity when t equals to 3, we'll have 12, 3 squared, minus 5 into 3, minus 3. And we key into the calculator, 12 into 3 squared, minus 5 into 3, minus 3. This gives us exactly 90. Exactly 90. The next, we determining the value of t when the particle is momentarily or instantaneously at rest. So instantaneously at rest means the values of t when the velocity of this particle is equivalent to 0. So we take the velocity function 12t squared minus 5t minus 3 equivalent to 0. So now we solve for t when the particle is 0. Therefore, we're going to have, let me use the factorization method, whereby I need the product of a times c. So 12 by -3 giving us -36. Then we have a sum of the value at b, which is -5. Now we need two factors. When multiplied, they give us -36, and when they are added, they give us -5. So let us look at -9 and +4. When they are multiplied, they will give us -36, and when they are added, -5. So we can now solve here. We can now solve for t. 12 t squared minus 9t plus 4t. That is now the substitution of -5, -9 and 4 minus 3 equals to 0. When we factorize 3t, which is common, we're going to remain with 4t minus 3, then plus 1, 40. Actually, we shall remain with the 40 minus 3 equals to 0. Therefore, the common factor is 40 minus 3. Then we have 3t plus 1, all equals to 0. So we shall have 40 minus 3 equals to 0, meaning that the value of t now is 3 out of 4, or 3t plus 1 equals to 0, which means the value of t would be negative 1 over 3. And remember, t cannot be negative, therefore we are going to stick to the value of t being 3 over 4. Now we can go to the other part, which talks of the displacement when the particle is instantaneously at rest. So displacement is going to be at t equals to 3 over 4, we're going to have the displacement function, and we substitute 3 out of 4. Therefore, we're going to have it as 4 t power 3, which is 3 over 4, cubed, minus 5 out of 2, 3 out of 4, squared, minus 3 into 3 out of 4, plus 3. So we have substituted the value of t as 3/4. And when we carry out such a substitution now, we can only use the calculator to get the final answer. Remember, this is 3/4, so 0.75. So 4 into 0.75 cubed minus 2.5 into 0.75 squared minus 3 into 0.75, then plus 3. This is going to be 1.0, or in fraction, 1 and 1 out of 32. That will be the displacement when the particle is momentarily at rest. Finally, we are talking of acceleration of the particle when t equals to 2 seconds. For us to get acceleration, we need the gradient function of the velocity function against time, or with respect to time. Therefore, because we have the velocity function here, then we differentiate it. We drop this power here so that we may get 12 times 2. That becomes 2040. Then the next is negative 5t. So this power 1. So we drop 1 there so that we have negative 5 by 1, making it negative 5. Yeah, like that. The constant disappears, of course. Now we want, because this is the acceleration function, we want the value of acceleration when t equals to 2. Therefore, we shall have 24 into 2 minus 5. When we take 48 minus 5, we get exactly 43.